Okay,
Stop.
I I thinks we're ready. Anyone here from Ken this morning? Because I haven't seen he hasn't put up a video yet for the game. Hmm.
Oh, geez. Couldn't we have couldn't we have hired a younger guy to do this part? I've got the experience. I just need a better face. Anyway, so I guess the CoCoIO is a project I did a couple of years ago, and it's been on hiatus because money mainly. But it's time to kind of that's probably solved, and it's time to get back to it. So I wanted to kind of do a flyby of the whole thing to date and see if there's any interest in how many cards, should I build and things like that. This all started watching Jim Brain had a network project a while back, and he had a lot of smart people, and it sure seemed like it's a lot of work. Kind of like playing background music without a sound chip amount of work. So you aren't really going to do a whole lot of processing while the Coco is doing networking because, well, same. And then now let's add some background music to the game and the networking. We aren't going to get anything done. So I'm looking around, and passing things off to a signal board computer isn't really a Coco project. It's just not what. So I came up with this, um, and this worked for a while. We even added a boot ROM to it. So here, this is just a straight up
Version 3.
we're doing we're ooh someone's got a call. So anyway, the whole byte banging thing of having to do every byte of Ethernet transfer seemed a lot. So we're using the WISNet chip. This is basically designed as a connect the refrigerator to the internet kind of thing. This little jewel right down here. Um, so we added a boot ROM to it, and a little bit of logic, and hey, we've got a network for our Coco. We'll get into the details in just a second, but the reason this died is because I wanted to rotate this switch. So I sent a new design to JLC with this switch rotated, no other changes. And they told me they couldn't build it because these two capacitors are too close together. So they kicked it back to, although no, they built this and there were no changes in this part of the board whatsoever. So okay, be that as it may, it got stuck for a while, but we're moving on. So we've got this, this sort of middle ground WISNet chip, and the way it works is you've got this shared chunk of RAM on the WISNet chip. There's 32K, half of it's control stuff, and half of it's your data. And you can, let's see, I'm getting off my map here. This can be either byte addressable or it's auto sequenced. So, you can use a TFM and just keep reading the same byte repeatedly and pull things out as fast as possible onto the bus. They give you just enough room with 16K for 4 ports, if you will, 4 frames of Ethernet in and out. And this is about what you need to run things at line speed. So the WISNet can receive as fast as someone can send it without having to worry about the server timing out. And then it can pause at a nice logical break in an Ethernet frame.
I'd like to inject here. This memory map is in the WISNet chip itself. It's not what the CoCo sees.
Yeah, the
CoCo sees just 4 bytes.
CoCo sees 4 bytes. There is a 2 address byte. There's a control byte, 2 address bytes, and 1 port, which can be any byte in this 32K. You can pick a byte, or you can just sequentially read the same byte over and over, put it in a mode where you just read FF6P over and over and over and over, and it works as fast as you can do that, which really helps in the way of, let's see, where am I going next? In the way of programming. So you can even do it in Disk Basic, and I've done so just to prove that it could be done. This was the hardware test program I wrote, because HTML is basically ASCII underneath. So what we've done is build our DOS-like thing by a couple of strings and putting the appropriate extra garbage at the end of each line. so that it looks like DOS line returns, and that way this is all prepared for us later. We don't have to think about it at the time. Like I say, this is just a test program. Let's see, what do? We configure the chip with just some direct pokes to show how simple it is. So we're 6.9 is the first address, 6A is another address, and we put it into auto increment mode by doing that. So data, 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 data. We're just counting our way up the stack, saving 2 bytes every time we poke to HH6B or FS6B here. So that's a good game. Once we set up the chip, it's as simple as we will send, we'll attempt to open a connection to the remote server that we just described, and camp on the status register to see if there's any bytes received. Now, normally you would then check to make sure that the buffer is full and it's time to move on, but because Disk Basic, we don't need to do that. If a byte's been received, the buffer's full, and we just move on from there. So we will do that and step through the buffer. And again, this is about as least processing as you can do. We're actually asking, the WISNet to handle all Ethernet stuff, put all the data in a buffer for us in nice order, and then we just run through it and print it onto the screen. And in a couple hundred bytes of Disk Basic, we've managed to dump a web page onto the screen. I think I deleted that by mistake. I did. So in short, you can run it just out of a little bit of Disk Basic if you want to. That's how simple the interface is. Like I say, your refrigerator could do it. So that seems to be a good middle ground. We don't have a lot of code on some single board computer external to the CoCo that's doing the work for us. This is all written by and for the CoCo, which is, that's fine, but shoot, I should stick with my script. I would be a lot. Okay, anyway, I'm blasting right through this really quickly, so I'm going to have to elaborate or ask questions or something. I guess after this little bit of Deck B proved that the chip actually worked on the CoCo, Henry Strickland to the rescue. He wrote some sort of basic, they aren't full-fledged utilities, they're the underpinnings of utilities. So this that's what the F's all about. This isn't a ping. This is the basics of a ping. You have to do some work to set it up, get it ready to go. But you don't have to do the individual peaks and pokes and all that stuff that we were doing in just BASIC. In OS9, you can just call FDHCP with the host name, and it will give you back the configuration, which is kind of a nice thing to happen. The only problem with these, this is demo code, so it's a single user network. Everyone, you know, it kind of depends on you being the only person that's doing networking from your OS9 install, because anyone else is going to stomp on you. That's something left for later. In fact, most things are left for later. So what we're going to do is just steal everything from Linux. I mean, no one knows OSK networking, so we're going to, in BASIC, write procedures to Linuxify, starting with the if up. So everyone could find the configuration for interfaces command. It's the interfaces in Linux. It's not something that's esoteric. You don't have to find it hidden in the CoCo, you know, in a CoCo book somewhere. It's all over Google, you name it. So we adopted it. You can define an interface. You can make it static or DHCP. If it's static, it uses these numbers. If you flip this to DHCP, it will ignore these numbers, but they're still there. So when you get back home, you can go back to the much faster static configuration. If it has to do DHCP, it needs to know your host name. So it uses syshosts, just like Linux, because that's something that is easy to learn. It's not too esoteric. Let's see. So we're getting back to those really basic commands. Given the information we were able to glean from those files, we can run fconfig or fdhcp, whichever one's appropriate, and set up the interface. So the user doesn't need to know any of the peaks and pokes or none of that stuff. Just write an interfaces file, and away you go. Then our next step along is finding people to talk to. The problem being, of course, there is an fdig thing as part of Frabio, but it's slow and it just gets the first result. In the real world, DNS is liable to come back with C record and another C record, and you chase this chain down till you finally get an A record, which is the actual machine you want to talk to. So we've written this BASIC09 program, which runs down that list for you and finds that final A record and saves it in a host file, which, just like Linux, is a list of all the hosts that you know the address for. So where are we? I should have practiced this one. I really should have. So anyway, the problem is it's glacially slow on a CoCo. So what we really want to do is look it up once, save it in a host file, and sit on it. This is a lot of string slicing. It's not really any networking. It's just managing that list of stuff based on ASCII that comes back. So it will produce a host file just like this. We're pulling every trick in the book. The ones on the top are entered by us, the users, and those won't be changed. That's going to be assumed to be the truth, no matter what. Below this comment, these have been found by running fdig, and if it's a C name, running it again and running it again until you get an A record. Then we save our A record here. Now it can take quite a while to get this on a CoCo. Talking a minute, which is quite the struggle. So you want to keep it as long as you possibly can. That's things got out of order somehow. Okay, so to get those numbers, you get to pick your own name servers, resolve conf, We've taken everything that's normally in Etsy and just put it in DDSys. Same name, same format, same comments. You can pound out a line. You can use this thing. We're just trying to be standard with somebody else's network book, so we don't have to write our own. Even to the point of how many, well, we won't get that far into the weeds. Here's the if config for setting up multiple interfaces. The one thing that we've added that isn't standard is the physical address, because we need to know that. So we'll just dump it in this file. I intend to change that into a comment. So if this file ended up in Linux, it wouldn't break anything. So trying to keep everything, kind of sideways compatible. Let's see. Okay, so we speed ran that. So I'm going to go to the game, which we have renamed Turk, not Trek.
Excellent.
It's not copyrighted, and B,
Yet.
you can Google it. Yeah. So we're going to be playing Turk.
I'll get the lawyers working on that right away for you.
So there's not really much networking in the networking game yet. We'll go through some play stuff. I wonder if I have that. Well, I'll just describe what's going on first, and then we'll go into some play stuff. We're kind of doing the opposite of a FujiNet game. There is no server. This is client to client on 60X09 CPUs. It can be CoCo's or Henry's, Bonobo, or TFR. Forget the numbers.
TFR9.
Yeah, the single board computer. Anything that can run BASIC09 and has more than 64K. I mean, you've got to be level 2, because the way we're fitting this all in is shared data module and processes running in different windows. So the chat window will be its own process. The game window will be its own process. Oh. This is how we're going to get everybody. Okay, I can talk again. So this is how we're going to get everybody onto into the 64K process limit. We're just going to use a bunch of 64K processes. So we'll see how that goes. Each machine, let's see, how can we hit this? So this is all client to client, and each machine is a site, if you will, with at least one human and up to 7 AI players. So as a single player game, you just fire it up on your CoCo and you've got 7 AI guys to fight, and away you go. As you invite more humans, they replace an AI and they take some of the load of the artificial players to spread the joy around. And the good side of this is if any human side drops off, that human can be converted to AI for the moment, and it'll sort of take care of itself. Excellent. As AIs will. And then if the human comes back, they can reclaim their avatar. They don't. So I got to thinking, how is this actually going to work? And one of
so you mean there's going to always be somebody to play with? Right.
Even if it's just you by yourself with 7 AI people, in which case you might want to just wait to see if your bros come back. But in any case, the concept is the whole game doesn't have to stop because one guy dropped offline for a minute.
Right.
Especially once you get to the point where humans are forming tribes together, because then your fellow tribesmen can kind of take care of you until you come back. So we've been, this whole writing the game before I write the game has worked out really well, because I've covered a lot of wrinkles. Let's see, one of the wrinkles is security, because any cryptography a CoCo could come up with, because this is a CoCo game, is just going to be smashed by the emulator pretending to be a CoCo. So solution is to not have any security. All the shared data has to be public. To make that complicated is the amount of data we have to transfer. So we can't send the entire map and player data every turn. Some players might be on a mode, so how do we handle that? We want the smallest possible data packet. And so we've kind of come up with some thoughts on that. I mean, it's not strictly a turn-based game, but if we have rounds, then within a round, we can randomly pick each player. So nobody's in strict order. You never know who came before you or who's coming after you. So it's almost as if it's all in real time. It's as good as I think I'm going to get with an 8-bit computer. So what we're going to do is we won't send the map on the line, so to speak. Players will start the game with the map and the data, and they maintain their copy of that and follow along with all the players in this ring network that we're about to set up. A little token ring. Should love that. It's period correct and all, right? So doing it this way, where the previous player tells you what commands he ran, then you recreate what he did on your copy of the map. And if the CRCs all match at the end, then everybody's kosher, and we didn't have to change that. We didn't have to exchange all that data. We both have still have valid copies. So that gives you, two stores to vouch for: the game program that you're running and the play data for the game that you're running. And that gives us this packet that's on screen here. The round we're in, the current player that's up, 5-byte real numbers is the random seeds that are going to be used. So everyone knows the random seeds that you have. And given that they now know your command string, who, what, when, that you did, they can recreate what you did because they're going to get the same results by using the same random seed. Now, no one will know real time which seed you're using or why or in what manner. So the fact that they learn these things, they only learn them right at the moment that they're expected to use them themselves to recreate your turn. So it's kind of security by timing, or I don't know how there's got to be a clever alliteration for that, but the security is you know everything just as fast as everyone else does. So there's no
Just-in-time security.
Exactly. There's no advantage to be gained by finding these things out. So that's what we're hoping to work. You'll notice there's a time shift here. If you're trying to put this together in your head, the first 3 lines are future, and the last 3 lines are past. And these first 3 lines are then memorized by the individual player, so they can, there's a turn and a half in here if you count knowing the last packet and knowing this packet. Let's see, where are we at? So I figured I would just kind of show a little bit of what it looks like running. We start the thing, and players randomly are given the token to play. I've got debug mode on so you can see everyone playing, and we have won the lottery. We are absolutely the last person to get to play in the first round. Now, normally you wouldn't know that. We just ended up here. But I'm tracking this on the right in my player debugging to make sure that all the baddies are doing the right thing, because this has been just a mess. I've put all of the players into one CoCo and one game, and yeah, the AI has been quite the bear to chase down. So we've been doing a lot of this. We run another couple of turns. This time I ended up being second in line, so pretty good position. I'm actually advantaged, although I don't know that except because I have debugging on. And you can see everyone's kind of moved around here, and people are chasing each other and closing in. I actually ask around. No one can tell me what this ruler that is done in the precise font the font width of the underlying print is, the thing that lets you slide up and down the page and find your right column. So I'm going to call it the Bosley after Mark's mom's tool that he put online there. So we've been watching people chase each other. They're supposedly doing the right thing. Right now we've got vision cranked up. This thing is balanceable. Everything is completely unbalanced so that aliens can see all the way across the galaxy and come attacking right away and things like that. And they're doing that. What we're hoping is the fact that this is all working on one CoCo means that once I split it out into networking, it will continue to work because I've ran into all the bugs in one cluster right here in the center. So we are, I guess basically this game is, there's an engine behind this. This game has I haven't done anything to try to be fancy with displays or anything like that. I'm going for the functional game, and then we can make it pretty later. So we are looking at just the hitboxes, if you will, just the bare map underneath, and in the future this might be, spaceships and stars and planets and all of that. But for the moment, just letters in a box. We're going for the function. And this is where I run into the end of my script, because I really had more planned, but I didn't get it done this week. Let's see, where are we?
That's okay. So you can get this code on a GitHub, right? I'll post the link here. So
yes, please just go to my GitHub, and we've got.
How would you implement a game playing it with somebody else? You're going to need the CoCoIO card, or at least the CoCoIO, probably with or without the ROM.
At this point, I'm glad you brought this up. At this point, I'm not using any of the tricks that we might pull with the WizNet chip. For instance, you could leave your game data on the WizNet because it's got that 8K buffer up and down. So you could theoretically leave the game map on the WizNet chip and never even move it into the CoCo in the process of playing the game. You just change the few bits that you want to change on the data on the network card, and then let the network card dump the whole thing free of charge to you. So that gives you a free, shared buffer that you don't have to maintain. And so when other people do their moves, it just gets dumped in your lap, and you don't have to copy all the stuff into your RAM. And anyway, I'm not doing any of that in this one. I'm trying to stay just, let's assume it's a network and or a serial port. And how will we do that? Are we chasing that question in any way?
Actually, my question was just if you want to play this against somebody, how do we get that set up? You're going to organize it on, Discord or Zoom or something. And then
here's the thing: this is a client-to-client situation. So
yeah, exactly.
The first person on their CoCo runs make game. Let's see, do I have? Shoot, I wish I had this handy. But anyway, there is a program that makes the game for you. I loaded the wrong thing on the CoCo. And this creates one human player and 7 AIs.
7 AIs. Okay.
So from there is another module, because we've only got 64K, so everything's a different module. Add game, which will allow you to add a different human player and their IP address or what serial port they're on, or so forth. And this added player takes over one of the AIs, and will also be assigned a couple of the AIs to run. So the processing spreads out among the CoCos that are online to keep everyone sort of evened up. And if you lose one guy, you haven't lost, 7 of 8 people. You can only lose half of the people in the game at one time. Once that happens, any game save file includes the players that are supposed to be part of that game. So at any point, you can save the file, and that becomes a valid stopping point. Now, if everyone keeps playing anyway, then that may not be the best stopping point, but it's valid. And it will know who all was logged in. And if it can reestablish with them, then they stay on as humans. And if it can't, then they become AIs. We aren't going to spend a lot of time figuring out who's here and why not. We're just going to, I mean, at this point, we're just going to get everything started. Let's see. I know.
Yeah, this definitely sounds like it would be something that would benefit from leveraging Brett's VPN that he made. We talked about it a month or two ago on the Coco Nation. Essentially, if you run a local Linux machine, you can set up a gateway, and you can then basically create a VPN that connects multiple systems, even behind NATed firewalls, to be able to communicate peer to peer.
Right.
Okay, we'll have to look into that.
Trying to keep up with my Coco only thing. I think what we're going for here is, remember the bit about host files and all of that?
Mm-hmm.
That means you could poke the people that you trust to be players in your game into the host file with their actual IP address, which would be their home address. And home to home, we miss a lot of the problems with trying to connect to some server somewhere that's going to want encrypted connections. I mean, me to you directly to our home IPs, IP4 is fine. You know, we don't need any security. As long as we know each other's address, we can trust that communication. And that's where I'm starting. I mean, we can get fancier with that, but just getting it working is my challenge right now.
Right.
Just getting a single user player working has been a 6-month process, and I dumped my demo that I was going to show, so that's my fault.
Star2 Baron, he's talking about 64K processes under OS 9. So your game, Rick, how many does that spin up? Is it 64K for each, not for each player, but for each?
Well, right now there are potentially like, hang on one second. I've got a doc. And we can do a little, okay, where are you?
I was saying what I saw in my mind you're describing it is that each player or whatever gets a 64K process. So your basic 09 game creates your basic 64K process, and it can spawn up other ones for the other.
I'll just have to wing it. I can't.
All right.
Visual Studio is running, but I can't find it. In any case, so what we've got is the game process, which is 64K. And it's going to speak with the shared data module so that it doesn't have to manage all of the communications. It can just say, here's my data. And that's going to use up that 64K, is just playing the game and assuming that it's spoon-fed its data. Alongside of that is the communication process, which is going to keep that data module fed. And it's going to do other nice things like the whole passing of CRCs. The game won't know how the CRCs are made or anything, because it's BASIC09 source. You don't want it to know how to do that. So
just consumer.
Right, and the player will have to run the right program, or it won't have the right source. So even if you have the wrong version, if you have the wrong game, if you tried to hack it, the CRC isn't going to match. Let's see, where were we?
Okay, well, Rick, we're up to...
I did.
We're talking about the memory space. Talking about the memory space again.
Okay, so yeah, the game shares the data module. We have the communication shares the data module, and then I want text chat as another module.
It needs to have text chat
because we've got the data module with all the connection things for everyone, and we know which WISNet ports we're using, and we'll have a spare port so we can throw text on that. Now this is gonna, Coco's gonna start getting slow somewhere in here because we've got 3 or 4 processes banging along. But I figure we'll get that far. And, you know, we've effectively got what, 256K worth of programs running now instead of 64.
Mhm.
The problem is I haven't figured out the data modules yet. There's a lot of clues on how they work, but
To be determined.
making it work, yeah. But that's going to be the secret of the whole thing is, and you might notice that this is all very simple displays. There's no graphics involved at all.
Mhm.
The idea is at this level, the game could run on a single board computer. It could run on an
Terminal.
Apple One. You don't even need
Yep.
cursor positioning. It's just a
Yep.
stream of characters, just like the ancient and honorable Apple or Teletype kid.
Yep.
That could be improved with a display module. There's the same data, but you know, tarts it up and makes a nice graphical thing. And if your CoCo or emulator has horsepower, then you don't have to look at the letters flying around in a grid. You can see, you know, sparkles and spangles and bright primary colors and swishes like all the modern games have got.
256 colors.
Well, you know, I'm not going to get into my modern game rant about any action creating spangles and sparkles and swooshes of purple and yeah, this is a stealth game. What's a swoosh of purple with sparkles mean? Oh well, anyway, so the idea here is we're going to stick with what OS 9 does everywhere, which is modules.
Lowest common denominator.
And
Yep.
and you know, you can
In text.
level 2 lets you just use up all the RAM you got. So we're going to try to split this up to use all the RAM we got and use the little bit of networking that the WISNet can provide us that doesn't tie up our processor doing that. And that should give us room to actually make an interesting game and still have it connected online without having to, you know, bit bang a serial port or byte bang a copy to a Raspberry Pi or something like
Or something
that.
running dry wire. Yep.
All right, so that's basically where I'm at on the CoCo. Like I say, I could have had a much better presentation, but
It's another thing we could do on a Cocotech sometime. This is just
this week has
get some
been a
stuff out there.
bear. In fact, I think we finally crossed 0 today. But you'll notice I'm still in my sweater.
Well, thank you very much, Rick. I'm sure we'll talk about this later because I love talking about this sort of stuff. And I am going to kill the stream for this, and we're going to do our few minutes of prep for the CoCo Nation for the next 2 or 3 hours, and then we should have the CoCo 4 presentation up in about 4 hours.
That's the other problem. I had to do that thing.
That too. Yeah, I know. Too few people and too much stuff to do. Well, again, thank you very much.
I need staff. I really need staff.
We all do. We all do. Okay, I'm going to pull the plug on this one. I'll turn this over to Mark B for getting the show up and running in the next 12 minutes, 13 minutes. So, okay.
2 minutes to get the music started. There you go.
Okay.